So with the day 3 material, cooling down a cup of coffee, the numbers are there. Okay. Now some people would say, oh, we have the numbers, we have the table. So let's go ahead and put in all the numbers down to the table, right? But then we have a problem. The problem is this. So it says the room temperature is what temperature? The room temperature of the coffee is 72 degrees, right? Fahrenheit. So that means eventually the coffee can only be as cool as 72 degrees in the room temperature. But when we do our regression, our graphing calculator, a lovely graphing calculator, it only does one thing. It only assumes the horizontal asymptote should go all the way down to 0. That becomes a problem. Our horizontal asymptote in this particular case, it should be at 72. So we need to do something to our data. Okay, so that's what makes day 3 material a little bit special. So what we do is that we have to manually change our temperature for the moment so that we can describe the proper relationship. So at this moment, the table that is given to you, it is assuming that the horizontal asymptote at 72. Now we need to pull the graph down basically by 72 units. So the temperature of 200 would become 128. So every single temperature reading, you will subtract it with 72. So at 0, it becomes 128. At 20, it becomes 105. You subtract, you minus one, you subtract 72 from 177 for the second row. And then at 40 minutes, the temperature was originally at 154, but you subtract it with 72. So that would be what? 82. And then at 60, 132 minus. Now, one thing is this. You may actually do this. You may actually just type in 132 minus 72. Okay, if you are a bit lazy like me, or you can just go ahead and say, all right, that's easy, that's just 60. Okay, so either way works. And then at 80 minutes, it will be 109 minus 72. That would be 37. And at 100 minutes, that would be at 14. Okay, 86 minus 72, it's 14. Okay, so again, we do this because our calculator does not know how to create a horizontal asymptote other than 0. So we need to help the calculator a little bit right here so that we will have a horizontal asymptote of 0 when we create our regression. So that would be your exponential. When the graph, it's when we have a cup of coffee that's cooling down, it's always an exponential function. Like the hotter it is, the cooler, the faster it cools down. But then as it cools down to the near the room temperature, it slows down its cooling. So you show exponential. So that's the equation right here. So you have 160, okay? You have 160.61454 times 0.979. Again, you can round it to the third decimal place. Okay, so that will be the equation of the data set. Well, actually, what's the first question here? Yeah, that will be the equation from the regression. But then when you actually write the equation for your data, okay, it would look like this. Okay, So I'm going to do a 160.615 times, open parentheses, 0.979 raised to the power of x. Now, that's after we modify the data table, right? But then, well, that's with the horizontal asymptote at 0. We need to put it back up to 72. So we will add 72 to our data point. Okay, we'll add 72 to our data point. So this will be our equation. And let me go ahead and readjust the window size so that we can clearly see what's going on here. Okay, so that's how we see our final equation. Again, our final equation would have to add 72 to push the graph back up. So that becomes our eventual equation. Okay, so that's the complicated part of this cooling curve.